Special triangles. This is a clutch lesson in that we look at exact values of some specific type triangles that tend to be repeated over and over and over again. So we're going to start off with a 45, 45, 90 degree angle. Now if I have, or triangle I guess, if I have a triangle that's a 45, 45, 90, has two angles that are the same, what kind of triangle do I have to have? Isosceles. It has to be an isosceles triangle. You cannot have two angles that are the same and not have an isosceles triangle. So if I look at this diagram here, if this is 45 degrees and this is 90 degrees, what would this be? 45. So there's my isosceles triangle. That means that this measurement here we'll call x. Has to be the same as this measurement here in order for it to be isosceles. So if I was to use Pythagoras' theorem, which I can use because it's a right triangle, it means that x squared plus x squared would have to be equal to 1 squared. So x squared plus x squared would equal 1. How many x squareds do I have? 2. So I get 2x squared equals 1. So then how would I get x squared by itself? Divide by 2. And how do I get x by itself? Square root. So I square root 1/2. So if I square root the top and the bottom, I get 1 over root 2. Which, if I wanted to have a rational denominator instead of this irrational value, I'd multiply top and bottom by root 2, and I would get root 2 over 2. So that would be the side lengths. This would be root 2 over 2, and this would be root 2 over 2. So if I go back through my sine, cos, and tan, sine is opposite over hypotenuse. So the opposite side is root 2 over 2 over the hypotenuse, which is 1. So I end up with root 2 over 2. And I would get the same thing if I had sine pi over 4, because in radian measurement it's the same triangle. If I look at a cos 45 degree angle, that's my adjacent over hypotenuse. So my adjacent side is root 2 over 2 over 1, which is still root 2 over 2. And cos pi over 4 would be the same thing. And then if I looked at tangent 45, tangent is opposite over adjacent. So it's root 2 over 2 over root 2 over 2, which is equal to 1. And tan pi over 4 would be the same thing. And I could double check these values using my calculator. If I typed in cos 45, I'm going to get a number that I think is something like 1.71, something like that, I think. And that would be equal to what root 2 over 2 is. If I typed in tan 45, I would get a value of 1. If I changed it to radian measurement and I typed in tan pi over 4, I would get 1. If I typed in cos pi over 4, I would get whatever root 2 over 2 is equal to. It's just my calculator can't figure that out for me in a radical, but we do have a way that we can trick it into doing that, and I'll show you that afterwards. So now let's take, our next triangle. Which is a 60-degree angle. So if I draw this triangle that's 60 degrees and this is 90 degrees, what would this measurement here be? 30. And then if I took this triangle and I reflected it, that means this angle here would be 30. This would be 60. The two 30s give me what? three side lengths are the same. This is 1, and this whole measurement here is 1. But what do I know about this line here? What did it do to the triangle?
Split it in half.
Split it in half. So what's the measurement from here to here? 0.5 or 1/2. We'll leave it as a fraction. So now I can figure out this height here. We'll call it A for altitude. So how would I figure out the altitude? Pythagoras theorem. So how would I use Pythagoras theorem to determine this?
1 squared minus 1/2 squared equals A square root.
So what is 1 squared?
1.
Okay. What is 1/2 squared?
1/4.
1/4. And 1 minus 1/4?
3/4.
So A squared equals 3/4. So then A would equal the square root of 3/4, which becomes the square root of 3. And what's the square root of 4?
2.
2. So again, if I look at my three trig ratios, sine is opposite over hypotenuse. So what would sine be equal to? Root 3 over 2. What would cos 60 degrees be equal to? One half. And what would tan? So then tan becomes root 3 over 2, opposite, divided by the hypotenuse. So root 3 over 2 divided by 1/2. What would that equal? And so then what would I be left with? Root 3. Did you know that if the denominators are the same when I'm dividing fractions, I can simply divide the numerators? Root 3 divided by 1. And then the denominators, in a sense, cancel each other out. Okay? And then my radian measurements would be the exact same. Now I can take this triangle and I can flip it around. So instead of having this 60 degrees in the corner, I can put the 30 degrees in the corner. And then what I'm doing is I'm basically taking this triangle and I'm writing it a different way. This becomes my 1/2 measurement because it's half of that equilateral triangle side. This side, we already actually solved it. We got root 3 over 2. So then when I look at my trig functions this time, what is sine 30 degrees? One half. Cos 30 degrees?
Root 3 over 2.
And then tan 30 degrees becomes 1/2 divided by root 3 over 2. Denominators are the same, so divide the numerators, and I get 1 divided by root 3. 1 divided by root 3. If I wanted to have a rational number as a denominator, what could I do?
Multiply by root 3 over root 3.
And what would that leave me with?
Root 3 over 3.
Why can't I square this? Because if I square root 3, I cancel it out. So why do I have to multiply it by this? Why can't I square it?
Don't you have to multiply by 1 so you don't technically change it again?
Exactly, because I'm not changing the value. This is still worth the same as this. If I took my calculator and I went 1 divided by root 3, I would get the same answer as if I went root 3 divided by 3. So I'm not changing the value. If I squared it, I would be changing the value. Okay? So here's our special triangles. We're going to complete this chart. take the numbers from the last 3 pages, or last 2 pages. So I'm going to give you a couple of minutes, and I want you to fill this chart in for me. Okay, so that's what I would get if I filled in the values into the chart. And now if I look at this triangle that has a horizontal distance of x, a vertical distance of y, the hypotenuse is equal to 1. So if I had to express the sine ratio, sine is opposite over hypotenuse. What would I get? Y over 1, which just equals, okay? What would I get for the cosine ratio? X, because it's adjacent over hypotenuse. And what would I get for the tangent ratio?
Y over x.
Y over x, good. Okay. Now we get into the unit circle. If we took these triangles and we put them on a Cartesian plane, we would get these points. These points correspond to whatever the x or the y would be. So if I take my first triangle, I'm going to take this one right here. That was my 30-degree triangle. And if you remember in the 30-degree triangle, the value of x was that root 3 over 2. And the value of y was 1/2. So this point here would be root 3 over 2 and 1/2. If I take my second triangle, which was the 45, that was the one that we said it was isosceles, so when we solved it, we took the hypotenuse, we divided it in half, and then we took the square root, and we ended up with root 2 over 2. And the x and the y's were the same. So this point here is root 2 over 2 and root 2 over 2. And then in my 60-degree angle, this measurement here was 1/2, and the height was now root 3 over 2. So the point would be 1/2 and root 3 over 2. This is the unit circle, so each of these hypotenuse measurements are 1. So when I get to this point down here, I have x being a length of 1 and y being 0. Whereas this point up here, my 90-degree angle, what's the value of x?
0.
And the value of y?
1.
Good. Now, if you remember what we said on the previous page, sine is equal to the y value. So if you took your calculator right now and you typed in sine 90, you would get a value of 1. It's equal to the y value. If I typed in cos 90, I would get 0. But if I typed in cos 0, I would end up getting 1 because that's my x value. So the question that asks, how do the coordinates of the points relate to the measure of the rotation angles? The x-coordinate is the cosine ratio, and the y-coordinate is the sine ratio. So then we recreate the chart that was on the previous page, this part right in here, but then we add in the values for 0 and 90 degrees. So again, I'm going to give you a couple of moments to do that. So if I look at these values, and I look at my points above, the sine ratio, or sine theta, is the y-coordinates as I go around in the circle, which becomes 0, 1/2, root 2 over 2, root 3 over 2, and 1. The cosine ratio corresponds to the x-coordinates going around, which is 1, root 3 over 2, root 2 over 2, 1/2, and 0. And then the tangent ratio is the value of is the value of the y coordinate divided by the x. So 0 divided by 1 is 0. 1/2 divided by root 3 over 2 becomes 1 over root 3, which is the same as root 3 over 3. Root 2 over 2 divided by root 2 over 2 is 1. Root 3 over 2 divided by root 3 over 2 divided by 1/2 becomes root 3. And then the last one, when I try to go 1 divided by 0, I can't divide by 0 so it becomes undefined. So y is tan pi over 2, or 90 degrees, undefined, because tan pi over 2 equals 1 over 0. And you can't divide by 0. So if you complete the following, just based on observation, the sine ratios go from what number to what number?
0 to 1.
Yep. Cosine ratios go from
1 to 0.
1 to 0. And the tangent ratios are equal to the sine ratios divided by the cosine ratios. I'm missing a page. Just give me. Oh, sorry. Okay. Now, if you turn the page, you get something that looks really scary. It's called the unit circle. Tell me something that you notice about the unit circle. One thing. What were you going to say, Jessica?
It's a circle.
It's a circle. Okay. That's fine. It's a circle. What's the radius of the circle?
1.
How do I know it's 1?
Well, because the coordinates are 1 and 0. So.
Because I have these coordinates 1 and 0, -1 and 0, 0 and 1. Okay. So because the radius is 1, that's why we call it the unit circle. What else do you notice about it? What do you notice about the 3 points that I just circled?
Well, they're the same numbers, but they're just positive, negative.
They're just positive or negative. And they're positive and negative depending on what?
What quadrant you're in?
What quadrant they're in. Because in this quadrant, x is
Negative.
negative. So that means this has to be negative. That's a good thing to notice. What can you tell me about all 4 of these angles?
All the same reference angle.
They're all the same reference angle, which is 30 degrees. So my same reference angles have the same coordinates. The only thing that changes is the quadrant that I'm in. So if I know that my reference angle is 30 degrees, and I'm in this quadrant, I know that these two numbers have to be negative. So really, the only part of the unit circle that I might need to know, and I'm going to show you that you don't need to know it, is the first quadrant, because I can reflect it into the other 3. If I have a reference angle of 60 degrees in the 3rd quadrant, this is 60 degrees in the 3rd quadrant, the coordinates there are the same as in the 1st quadrant, except that they're both negative. Okay? It says recall the formulas for sine theta, cos theta, and tan theta, and cotangent theta. Tangent and cotangent are actually on your formula sheet. So those ones you don't necessarily have. I think they're on the formula sheet. No, sorry. tan theta equals sine over cos, and cotangent equals cos over sine is on your formula sheet. But these ones I can get by going back to that SOHCAHTOA, opposite over hypotenuse. In the unit circle, when r is equal to 1, sine theta will be equal to the y coordinate, and cos theta will be equal to the x coordinate. Alphabetical order, x comes before y, cos comes before sine. So now I'm going to show you a calculator trick. If I was asked to find out the exact value of, which one do I want to pick? Let's start with sine 45. So I grab my calculator. What mode should I be in? Degree mode. So make sure you're in degree mode. So degree mode. Sine 45. And I get this 0.7071, et cetera, et cetera. I know, according to my chart, that sine 45 is supposed to equal root 2 over 2. And actually, if I put in root 2 divided by 2, I get this number. But there's no button on my calculator that will change 0.7071 and put it into this radical form. So, what do I know about this number, this root 2 over 2? What number system would it belong to? Pardon?
Real?
It's real, so that's the biggest one it belongs to. What's the smallest one it belongs to? Is it a natural number? Natural numbers are counting numbers. Is this a counting number? No. Is it a whole number? Is it an integer? Is it a rational number? Rational numbers are what? They are fractions that the decimals either repeat or terminate.
Irrational.
It would be irrational because what do I know about root 2? Root 2 is an irrational number. So I know that this decimal is going to extend on. The other thing that I know about irrational numbers, or square roots, what happens if I square a square root?
Cancels out.
Cancels out, and I end up with 2. So if I could take this irrational value that I have here and square it, it would kind of cancel out that square rooting factor. And what do I get? I get 1/2. So I take this value, this 0.7071, and I square it. And that gives me 1/2. Have I changed the value, what it's worth? Yes, I have. So how do I fix that?
Just square root.
Just square root it. So square root 1 and I get 1. Square root 2 and I get root 2, which when I rationalize it, gives me root 2 over 2. So if I take another one, such as sine theta, sine 60 degrees. What do I get when I type in sine 60 degrees?
0.866 on the other one.
So 0.8660, et cetera, et cetera. So then what do I do?
Square it.
And what do I get? 0.75, which as a fraction is 3/4. And then what do I have to do? Which gives me root 3 over 2. You no longer have to memorize those ratios. Chances are you use them often enough, you'll remember as soon as you see 0.8660, yeah, that's the root 3 over 2 one. Because you'll work with it often enough. If I go into radian mode, and I want to calculate cos pi over 6, it is going to be the exact same method. Only now I go into radian mode first. And it's cos pi divided by 6. And there's my 0.8660, which when I square it, gives me 0.75, which as a fraction is 3/4, and then I undo the squaring. So how are we so far? Good. Because now we're going to take a look at the examples that are on the next page. And this part here, when it says use a circle, unit circle, we're not going to use the unit circle because you don't have the unit circle on the test. I don't want you dependent on the unit circle because you're not going to have it to refer to. So we can use the calculator. I'm going to give you a couple of minutes and see where you guys can get on your own with these two class examples.
You just flip them around.
So, what is sine 300?
Negative root 3 over 2.
Negative root 3 over 2. Because I'm in the third quadrant, or sorry, the fourth quadrant, sine is negative in the fourth quadrant. What about cos 300?
1/2.
Tan? Okay, but I'm in the fourth quadrant, which means it would be negative. So when I type it into the calculator, so when I type in tan 300, my answer comes up as negative. So after I do the squaring and the square rooting thing, I have to remember that my answer was negative to begin with. And then my reciprocal trig functions are reciprocating each of these. Which, if I rationalize them, I get negative root 3 over 3. And this one I get negative 2 root 3 over 3. If I was to find the exact value of the next three, I would probably start with this tan 600 simply because my calculator is already in degree mode. And what I would get would be root 3. And then the next three I would change back into radian mode. And I get negative root 2 over 2. Negative 1 over root 3, which then becomes root 3 over 3, negative. And cosecant 3 pi would become undefined. Because it's 1 over sine 3 pi, and sine 3 pi is 0. For class example number 3, it says use a calculator to determine to 4 decimal places the coordinates of the point on the unit circle that corresponds to a rotation of 2/5 pi. So that means that I have this rotation, it's 2/5 pi. And I have this point P, and I want to know what those coordinates would be on the unit circle. What I need to remember is that these points are cosine theta and sine theta. So point P would be cosine pi over 5 and sine 2 pi over 5. So that's what I would type into the calculator. What do I get when I type in cosine 2 pi over 5? When you have an answer, yell it out.
Can you just do like decimal places for
Yeah.
0.3090?
Yep. And what's sine 2 pi over 5? In class example number 4, you're given 2 points on a unit circle. And you're asked if an object goes counterclockwise from point P to point Q, what angle has it rotated? And they want the answer in both angles and degrees. So when we go to calculate this, what quadrant is point P in? Quadrant 4. Because I have a positive x and a negative y. What quadrant is point Q in? 2. Because I have a negative y and a positive, a negative x and a positive y. So I need to figure out some angle measurements. How can I figure out the angle measurements? Because I don't want to use the unit circle because I don't have access to it on a regular basis. So what do I know about these x and y values? What do they correspond to? Cosine sine. So what this means is this point down here means that cos P is equal to root 2 over 2. So find out what the reference angle, what the angle is going to be. And I find that by doing my cos inverse. What'd you get? What'd you get, Hannah? 45 degrees? If I was in radian mode and I did this, so I go cos inverse, root 2 over 2. So root 2 divided by 2. And I would get this number here. And we talked about how we could convert this into radian form. We would divide it by pi. And then I get that fraction, which is 1/4. And then I would put multiply that by pi again. So I would get pi over 4. So that's this measurement right here. Now if I do the same thing with Q, and I'm going to do sine Q. So if I did sine Q is equal to root 3 over 2, angle Q would be equal to what? Yes. So the part that is 60 degrees is this part in here. Because it's that reference angle. And 60 degrees is pi over 3. 180 divided by 3 gives me that 60. Because pi is 180. So how do I figure out the angle rotation? I want to go from P to Q. So how would I do that? What do I know this is? 45 degrees. And what do I know this is? 90 degrees. And what do I know this piece here is? 30, because the other part was 60. So how many degrees is that?
165.
Yes. In radian measurement, I've got pi over 4 plus pi over 2 plus pi over 3. What's my common denominator? 12. If I change these all to 12ths, I have 3 pi over 12, 6 pi over 12, and times 4, 4 pi over 12. So 3 plus 6 plus 4 gives me, wait a minute, that's not right. Times 3 times 6 times 4. Oh, because this isn't pi over 3. This is pi over 6. 30 degrees. So then this should be 2 pi over 12. So 3 plus 6 plus 2 is equal to or I could take this 165 and change it into degrees, or change it into radians. Okay. Without using a graphic calculator, determine the exact value of log base 2 cos 7 pi over 4. Again, there's not a part of the test where the calculator is taken away from you. So cos 7 pi over 4 equals what?
Negative 14 or negative 1/4.
Negative what?
1/4. Or like, do you have to do the square and square root thing?
Yeah.
Oh, okay.
To be negative. So you got 1/4, and what happens when I square root 1/4? I get 1 over root 2.
Well, but I got 1/4, negative 1/4 before I squared it. Like, I'm really confused.
Cos 7 pi divided by 4. You should get 0.7071 before you square it, Rachel. And then when I square it, I get the 0.5, so I get 1/2. And then I square root 1/2 and I get 1 over root 2. Are you in the right mode, Rachel?
What mode should I be in? Like I'm in radian.
Yeah, that's the mode that you should be in.
Mm.
Can I see? So, if I don't worry about rationalizing the denominator with this, I get log base 2 of 1 over root 2. How do I write root 2 as a fractional exponent? How do I take the square root and write it as an exponent? 1/2. If it's on the bottom, how do I bring it to the top? Negative 1/2. What can I do with the negative 1/2?
Bring it to the front.
Bring it to the front. And what's log base 2 of 2?
1.
So this would equal negative 1/2. So we used the calculator just to help us get the cos 7 pi over 4, but we did everything else using the log rules. Okay, I'm going to finish this last example. Point A lies on the unit circle. Determine the value of theta, where theta is the angle made by the positive axis in the line passing through A. What quadrant is A in?
3.
Quadrant 3. So I want to know what this angle is. How do I do that? What do I know about these points?
Cosine.
They're cosine sine. So that means that cos A is equal to negative 0.6157. So what I'm actually going to determine is I'm going to try to find out what my reference angle is. So when I do my reference angle, use the positive value, not the negative. And what mode should I be in? Well, it doesn't actually tell me what mode I should be in. So I could be in either mode. Which mode's going to be easier?
Degree.
Let's go into degree mode then. And when you have a reference angle, shout it out. So 51.99, which would be 52 degrees. So what would angle theta then have to equal? Which equals
132.
And if you go cos 232, do you get a number that's very close to this one?
Yep.
And if I went sine 232, do I get a number that is close to negative 7.7880? Yes. Okay, so questions. Questions 2. A, C, and E. Three, A, C, and E. 4, A, C, and D. They're dealing with reciprocal trig functions in number 4. Question 5C. Uh, 6B and 7. Okay, so continuing on with this lesson, the other way that we can solve these special or exact values is the use of reference angles. So if we take a look at sine 210 degrees, it's in quadrant 3. The rotational angle 210 has a reference angle of 30 degrees. Being in quadrant 3 and being sine, it means that I'm negative in this quadrant. So if I'm negative in this quadrant, then I have to remember that fact, that my sine value is going to be a negative value. In fact, we can say that sine 210 degrees is equivalent to the negative sine 30 degrees. So then I grab my calculator, and I'm going to make sure that I'm in degree mode. And then I'm going to calculate sine 30, which is 0.5, which is 1/2. So then I make it a negative, and I get negative 1/2 is what sine 210 will be. So now if I look at cos 5 pi over 3, that means I'm in thirds, so 1, 2, 3 thirds, 4, 5 thirds. So that puts me down into quadrant 5, or sorry, not quadrant 5, quadrant 4. My reference angle, if this is 5 thirds, what's left over is pi over 3. This is in quadrant 4, and the cosine ratio is positive. So then cos 5 pi over 3 is the same as cos pi over 3. So then again, I grab my calculator. This time I'm going to be in radian mode because my angle was given to me in radian mode. Cos 5 pi divided by 3. Make sure this all goes into brackets because that's the measurement of the angle. And I get 0.5 again. So cos 5 pi over 3 is equal to 1/2. So then the last one, cos negative 225 degrees. Negative means I'm going counterclockwise. 90, 180, negative 210 is going to put me up here. So I'm in quadrant 2, and in quadrant 2, tan is negative. My reference angle, this is going to be basically, it's kind of the difference between 225 and 180. So that will be 45 degrees. So I can say that the tan of a negative 225 degree angle is the same as the negative tan of a 45 degree angle. So then again, I'm going to grab my calculator, I'm going to put it into degree mode. Tan 45 degrees, and I get 1. This is a negative, so it becomes negative 1. So that's how we could use reference angles in order to determine or to do these calculations. Okay? So now into the next part, the equation of a circle. If I let point P be any point on the unit circle as shown in the diagram, the coordinates of point P are going to be x and y. Then what I can do is I can use the Pythagoras theorem to determine the equation of a unit circle. In Pythagoras theorem, I've got a right triangle. So the relationship is I square this side, square that side, and it equals that side squared. So the equation of a unit circle would be x squared plus y squared equals 1 squared, or just 1. Now suppose instead of it being the unit circle, it is any circle that has a center at the origin and a radius of r. What would I do to calculate the equation of the circle? It would be x squared plus y squared, instead of equaling 1, is going to equal r squared. So if I look at class example number 7, it says, determine which of the following points lie on the unit circle. Well, if this point lies on the unit circle, it has to make this true. So if it's on the unit circle, the radius has to be equal to to 1. So if I calculate this out, 1/2 squared plus 1/2 squared is 1/4 plus 1/4, which is 2/4 or 1/2. That's not equal to 1, so this is not on the unit circle. So take a moment, pause, and then try to do B, and then when you're ready, press play to see if that one works. So 16 over 65 squared plus 63 over 65 squared. So if I take my calculator, bracket 16 divided by 65 squared plus bracket 63 divided by 65 squared. Enter. I get 1 for an answer. So yes, this is in fact on the unit circle. Okay, take a moment and try to do C. So I could do this on my calculator, or I could do this using mental math skills. 2/3 squared is 4/9. Root 5 over 3 squared. Root 5 squared is 5. 3 squared is 9. 5/9 plus 4/9 is 9/9, which equals to 1. So class example number 8. This point lies on the unit circle in quadrant 3. So there's where it lies. The x value is -1/5, and then I need to figure out my y value. So it says determine the value of y. Well, I can take apart, or I can kind of reverse the process of Pythagoras' theorem. Instead of this squared plus this squared equaling 1 squared, I can say that y squared will equal 1 squared minus -1/5 squared. -1/5 squared is 1 over 25, minus 1 becomes 24 over 25, and the square root of that, so then y would equal the square root of 24 over 25. The square root of 24 is 2√6, and the square root of 25 is 5. So I get 2√6 over 5, but because I'm in quadrant 3, this has to be a negative value. Okay? Point P lies on the terminal arm of this rotation angle. So the question is, what are the exact values of secant theta and cotangent theta? So secant theta, wrong color. Secant theta is 1 over cos theta. And cos theta is opposite over hypotenuse. So cos theta is -2√6 over 5. So when I go to divide that, I'm going to get 5 over 2√6. Sorry, -5. I could leave it like this, or I could rationalize the denominator, multiply top and bottom by √6, and I would get -5√6 over 2. Okay. The reason why this is 2√6, remember 24 I can write as 4 times 6. Square root of 4 is 2, and then that leaves me with √6. For cotangent theta, there's 2 ways I could do this. I could do this with the rule that this is 1 over tangent theta, or if I look on my formula sheet, it also tells me that it's cos theta over sine theta. And if we remember from earlier, cos theta was my x-coordinate, sine theta is my y-coordinate. So this becomes -1/5 divided by negative 2 root 6 over 5, because those are the values. If the denominators are the same, I can divide the tops, and I get 1 over 2 root 6. The positives cancel themselves out. Then again, I can do this rationalizing. So I get root 6 on the top, and on the bottom, I'm going to get 2 times 6, which is 12. And then question C says, determine the value of theta to the nearest tenth of a radian if theta is between 0 and 2 pi. So again, what I could do is I've got that cos theta is equal to my x-coordinate, which is negative 1/5. This is in quadrant 3. I can then calculate my reference angle by going cos inverse 1 divided by 5. I don't worry about the negative. I'm in radian mode and I need to be to the nearest 10. So radian mode, and it's cos inverse 1 divided by 5. My reference angle is 1.3694, etc. So 1.3694 on and on. So in quadrant 3, I figure out the rotational angle by taking the reference angle and adding pi. So I still have this in my calculator, and then I can go plus pi, and I get 4.511. So I get 4.5 radians is theta. Okay, one more question left. Determine the equation of a circle with a center at the origin and the radius of 8 units. So I get x squared plus y squared equals r squared. I'm at the origin, that doesn't affect the x and the y. The radius is 8, so this would now equal 64. And then B says if this point lies on the circle, determine all the possible values of B. So if it lies on this circle, meaning that it equals 64. So I get negative 4 squared, because that's my x value, plus b root 3 squared, because that's my y value, equals 64. So I get 16 plus 9, or sorry, not 9, 3b squared equals 64. Subtract 16 from each side. 64 minus 16 is 48. Divide both sides by 3, and b squared equals 16. Take the square root, and I get a positive or a negative 4. So those are my possible values of b. In addition to the questions I gave you yesterday, you're going to add in 11 and 12, 14, 15, and 16.